everyone. Hope you are doing well. In the last lecture, what we have discussed, I hope you have you have gone through this. So, with the continuation of the last lecture, so here in this lecture, I want to discuss some elemental thing. The elemental thing is in the basic electrical engineering, you might have solved the network, lot of network. Okay, in the network, main thing is that the source network contains source and loads. Electrical circuits. So electrical circuits at least will contain at least one source and load. Okay, so you might have got as a not only one source, 1, 2 source, 3 source, 4 source, whatever it may be, the current source, maybe the voltage source, and the loads elements are content R, A, C. R means resistance, L inductance, C means capacitance. So these are the element for the AC circuit. Means if the circuit is having connected with the source, AC source. Okay. Now what these? Why these are RLC in electrical engineering? So as the load, you will get RLC. What actually basically the applications? What are the appliances is there? So the motor, single phase induction motors, 3-phase induction motor, synchronous motor, etc. are basically the main motors. Okay, so what you will see in this, so these motors are will behave as a load. So but actually these motors are equivalently you can present in terms of RLC, either means a parallel combination of RL or RLC. Okay, so in the further course you will see how these motors is equivalent to RLC, the combination of RLC. Okay, so in the previous lecture we have discussed for a typical sinusoidal signal. From that signal in time domain 2 we converted into the spatial coordinate. Okay, so in spatial coordinate what we have seen? We have seen the RMS value of that particular signal. RMS value of a particular signal, it rotates with a speed, particular radial frequency. This is the RMS value of that signal. It was, and it rotates in the anti-clockwise with the frequency. Okay, with a speed, with a common speed, the radial speed 2 pi f. Okay, now actually we know, means just we discuss the RLC is consist with a as a load element. Okay, so now if the RLC presents in the network, so what will be the nature of the elements of current through? Suppose R, current through resistance, current through inductance, current through capacitance. So these things will get. Okay, and also as well as we will see the voltage across this element, resistor, voltage across inductor, voltage across a capacitor, and also we will will be interested on the voltage, source voltage and the source current. Okay, So for that, just we have to see the scenario what we will be seeing. So for if suppose one typical source is there, AC source, purely sinusoidal AC source, suppose this is a voltage source and it is connected with the resistance R. Okay, now what if this is a source, suppose this source is RMS value is V, suppose instantaneous value of this, suppose Vm sin omega t. We are taking this Vs as a RMS value of this source. And now what if this voltage source is connected with this resistance? So this resistance is now what in parallel with this source. So how much? So the voltage across this resistance is what? VR, nothing but Vs. So if you instantaneously, what will be the current through this resistance? VR Vm sin omega t R. Clear? So what will be the IR? Vm R sin omega t. Okay, so in this omega is a radial frequency. So if this element is there, okay, if the frequency source is with a omega radial frequency and this source, current source also with a omega frequency, so we can consider Vm by R as a Im sin omega t Im sin omega t, and also the V supply voltage and the resistance across the voltage is same, equal to VR. So this is Vm sin omega t. Clear? So previous lecture what we have seen? We have seen this is the time axis. So for a sinusoidal signal, particular sinusoidal signal, okay, so particular sinusoidal signal at this instant, at t equal to 0, at t equal to, it is completing, suppose the time period t, here it is t by 4, t by 2, 3t by 4, it's completing t. Okay, at t equal to 0, at t equal to 4, so how, what we got? So the RMS vector is rotating at t equal to 0 at here, so it will go, this vector will rotate and the position at t equal to t by 4, and here and here, and like this, it in this way it will rotate. Okay, now it was like that as signal. Suppose in the same way, suppose this signal we are considering Vm sin omega t. So if it is the signal source voltage, okay, the source voltage RMS value instantaneously is V. So this voltage is nothing but the voltage across resistance. So this voltage across the resistance. Okay, now the current as we know, the Vm by R. So Vm by R, so this peak value for V is, it is the peak value and this is the minimum value. So now what would be the current? Current means I instant, I current through resistance, Vm by R. So obviously if R is greater than 1, then it will goes up the maximum value. If it is lower than greater than 1, it will the lower of the Vm. Okay, so now let's consider R greater than 1. Okay, so obviously the current through this current, instantaneous form of that current would be like this. it would be like this. Okay. So now for this current, this is the instantaneous form. So for this current as also we'll get a RMS value. Okay. So this RMS value, this current is suppose current through resistance. So for this also, for this instant, the vector would be at this way. So this RMS, current RMS, at this instant it will come at here, and for this instant it will come at here, for this instant it will come at here, and in this way it will rotate. Okay. So this simply meaning is that, so in any other other way you can present it is like this. Suppose in first instant at t equal to 0, so V in this way with magnitude the RMS. Okay. Okay, the source voltage, and current also in this way. So this is current RMS. Okay. So you can shift in the space because these vectors are rotating in space. Okay. So you can everywhere you can displace, but the direction of these vectors would be in the same direction. Okay. Suppose t equal to t by 4. What? So the vector it would be in this way, VRMS, and it would be in this way, the IRMS. Okay. And for the t by 2, what? In this way, VRMS and IRMS would be in this way. So how? What is the meaning of this? This is the rotation. Actually, this is the rotation in this way with omega frequency, angular frequency. Relationship between this. So current through the resistance and current through the this element would be in the same way. Okay. Because here how many components would be there? For one component, so for source we will be getting Vs, Is. For the resistance, Vr, Ir. So for the source also, the Ir here in this case it will be equal. Okay. So there 3 components will be getting. Okay. And 4 component. One source current, one source voltage. Okay. One voltage across the resistance, one current flowing through the resistance. So this current and this current is equal, actually same vector. This also and this also will be same vector. Now the thing would be, so for the inductor, why the inductor is, it is like this. Okay. So how the inductor will behave for this? For this case we can take as a current source. This is a source current, RMS value. So I, we can consider Im sin omega t. Clear? And the pure inductor we can consider. So across this we can consider VL. So this across this inductor, what is the voltage across this, and current source across voltage, source across current source across this current source we can consider the voltage Vs. So these also are parallelly connected, so Vs and VL would be same. So this is RMS value. Okay. So now what would be the current? So VL equals to L DIL into dt. So DIL means what? This is current through the inductor. So current through inductor is nothing but the source current is drawing from this source, this current. So Is equal to IL. So if Is equal to Im sin omega t, instantaneous current. So what would be the voltage? So this is L is what? The inductance value. Inductance value is L. So now this is the constant for a particular inductor. Okay, so now this L d by dt Im sin omega t. So omega is for this particular source, omega would be constant. Omega would be constant. So what would be the Im is the maximum value of that signal, the current signal. So it would be the L Im, okay, omega cos of omega t, cos of omega t. So how we could present this L omega Im? So this would the sin omega t plus 90 degree, we can present in this way, because the sin omega t, we know this, the all sin tan cos means what? The sign in the third coordinate, the second coordinate is positive, so it would be the cos omega t. Clear? So this equation we can consider this one as a Vm sin omega t plus pi by 2. Okay, so now any of this signal, if we take as a reference, so first one, suppose we are taking the current source we are taking as a reference. So this current source is common for this inductor. So if you take the reference as a current source, so what will be getting? So in this way you will be getting the source. Okay, so at t equal to 0, t by 4, t by 2, 3t by 4 and t. Clear? So in this way you will be getting, this is type. But for voltage at t equal to 0, the voltage across the inductor, the t equal to 0, it would be how much? Sin omega at t equal to Vm. That means maximum. So that is maximum. So at this t equal to 0 instant, so it would be at maximum position. But for at this point it will be, at this point it will be the minimum. Okay, so in this way we will getting at this point it will be maximum, minimum, maximum, and it will be maximum. In this way you will be getting. Okay, now see, at this point for this is the current and this is the voltage. Okay, so for this at t equal to 0, okay, at t equal to 0, suppose if you shift in this way, okay, if you shift in this way, okay, so where it would be? So the current would be at this position, current would be at this position, but voltage high. So for this, if this is rotating, this current is rotating with RMS value at this in this way, if it is rotating current. So now on the position of this VL, how it is rotating at this position itself, what would be? So it would be at this here, this is PL. Okay, in the separate way. Okay. So PL at this position here at t equal to 0, t equal to 0 here, t equal to in like this. So in this way it will rotate. Okay, but for current it was t equal to 0 at this here in this direction, but at t equal to 0 the omega L it will VL. Okay, because the instantaneous position would be here. Okay, but the RMS value would be same and it would be rotating in this way. So in the current and voltage, so for a particular instant it rotates like this. Okay, so there is an angle between this 90 degree, so there would be, and in this way it is rotating, so current is lagging, current is lagging by how much angle? 90 degree. Okay, so there would be a 90 degree lagging for inductor. Okay, so what is the meaning of this? This means at t equal to 0 current in this way and the voltage this way. Okay, for t equal to what? T equal to t by 4, current here and the voltage here, current and voltage. Okay, so but they are rotating in this direction, there. But they are displacement, there is a displacement always all time 90 degree. Okay, so this is the phenomena of rotation of each and every vector. Okay, the current and voltage. Okay, these are the known as the phasor. For the capacitor in the same way you will get. So for the capacitor, if you take one voltage source, the capacitor, so for the capacitor current, as we know the capacitor current is C dVc by dt. Okay, from this equation in the same way you can find what you can find the relationship between the voltage and current, voltage across the capacitor DC and the voltage current through the capacitor, displacement current through the capacitor C. So it will be rotating in this way and there would be the current is leading by 90 degree the voltage. But in case of inductor, what it was, the current was lagging 90 degree, but in case of capacitor it would be the lagging 90 degree. So this would be your facts. Okay, how it is, but this lagging, it is how it is capacitor and voltage in the same way what I did in the inductor. So you have to show. Okay, just check for your better understanding. I want to solve one problem. The problem is like this: the basic electrical problem. So this is the source RMS value. So the source is Vm sin omega t, means what? Once this is AC source. Otherwise, if in case of DC, what would be the, in case of DC there is a no frequency, there would be no phasor because there would be no rotation. So this you can remember these things. Okay, so for AC only the phasors rotates. Okay, but in case of DC there would be no phasor like such that, because there is a no frequency. so there will be no rotation. Clear? So if you take this element R and other elements, the inductor and here the capacitor. So before going to present in the phasor of this diagram, so firstly what we have to see, we have to just think about the what are the elements we will be getting from here and what are the equation you will be getting. So suppose from up to this network, what is this is the equivalent of RLC parallel combination. So in this network what we could present, in this also we could present na? So this is R and there is an equivalent of something, because this network is presenting that is R, so this okay, so there would be a equivalent current for this component. Okay, so and the voltage relation, this is source voltage, this is across the resistance R. So firstly find the IR, current through resistance, current through inductor IL, current through capacitor, and voltage across this inductor and capacitor both are same because they are parallelly connected. Okay, so VC, VL are same, V as a V. Okay, if you see, and these are equivalently presenting. Okay, now for this there would be a difference because not many elements we got na, ES, IS, DR, IR, IL, VL, IC, VC, all those terms are there. So any from any one of them would be reference, you can consider as a reference, but there is a common element. If you find there is a common element, so it would be your better, means very simple to present. Okay, means the phasor will be easy to present. Okay, otherwise any one you can take as a phasor. Okay, I am sorry, you can take as a reference. Okay, so let's take here this voltage across inductor and capacitor, and immediately you try to establish the current. So there is a relationship would be the IR would be the this current through this branch with equivalent current, there would be equivalent current. Okay, so the for voltage VS is current through voltage across V and voltage across this voltage across this. So this equation will get and this equation will get. So firstly we want to explore this section. So what would be getting for this section? So for this section, this is the voltage, we are considering V as a reference. So if it is reference, okay. Now for the inductor, the current is what? Lagging. So this current is lagging by 90. So as you know, the for inductor the current is lagging by 90 degree. So voltage is across inductor voltage V and the inductor current through inductor is IL, and the current through capacitor is leads by 90 degree. So see here, IL and IC, they are opposing each other. So if there is any condition, the IC and IL is like opposing each other, so there would be what? No current, resultant current would be. But in some case, if it is not like that, suppose we are taking as a IC greater than IL. So what would be the presentation would be for this V and IC minus IL. Okay, so this is the equivalent current. Okay, so if it is equivalent current, so for the other part is there also, and this current is nothing but what? If it is current equivalent, so this current is nothing but IR. So IR and I equivalent is the same. Now VR and IR. So in this way only IR. So this is IR. Now as we know what VR and IR for the resistance. So they are obviously they are only in the same place. So VR would be in the same direction. Okay. Now what we could get? So there is the equation Vs VR plus V. So what would be the presentation of VR and Vs? So if suppose VR in the same direction, then VR. So VR and V. So this would be the what? The resultant of VR and Vs would be the source voltage. So this is the angle between source current, that means IR. Source current is equal to the IR, current through resistance, and the current through the equivalent portion what we have taken for RLC configuration. Okay, so in this way it will rotate. Clear? So if we simplify these things, okay, now what are the components we got? So this equivalent component is acting in this way. Okay, the voltage across inductor or capacitor in this way, and the current through resistance also, this current through source also this. Okay, and voltage across the resistance also VR, and this way we present we got this Vs and the source current this. Okay, so these are the elements. Okay, for a particular instant we got this rotation. Okay, for a particular instant we got this the position, but they are all the vectors are rotating in the synchronous manner with all the vectors are rotating with same frequency. Okay, suppose there is in the same network, if we consider that there are two frequency, suppose omega frequency and 3 omega frequency, then what would be the Phasor diagram? So Phasor diagram would be for omega it would be different, for 3 omega it would be different. Okay, so at the same frequency one phasor would be there, for this frequency another frequency would be there, so it would be like this. Okay, so so the key points of this so far what we have discussed, key points are Now what is the phasor? So phasor are the vector components. These are the current or the voltage. Maybe current through that element and voltage across that particular element. Okay, so these are rotating, okay, in space, but the method of this presentation is in for a particular instant we have to present the phasor. Okay, but otherwise the vectors, the phasors are rotating, okay, with a same frequency. Okay, and for the inductor, current lags voltage by 90 degree. For capacitor, the current leads voltage by 90 degree. Clear? Home tax. So you try for this phasor diagram. So this is the voltage source, and this is resistance, this is inductance, this is capacitance. Okay, and there is a resistance and inductor. Okay, what would be the presentation of this? R, L, C, L, R. What would be the phasor diagram of this? IR, IL, IC, and here IRL. So hope you understood this phasor diagram conception. With this, lot of things we have to do in phasor only, in transformer, induction machines, synchronous machine. Lots of phasor diagram supposed to be draw in your future course. So thank you all. God bless you.